Okay, we're going to tie up all the loose ends of Chapter 11. So far, we've talked about quadratic equations. So we have done this much so far. And we have solved quadratic equations by factoring, when appropriate, the square root property, completing the square, and finally the quadratic formula. That's all for a quadratic equation. Now you notice that the only variable here is x, and it is a quadratic equation in one variable. Now, we have talked about functions, and functions are relationships between x and y. We can call them f of x, or we can call them y. Now, a quadratic function, you can see on the right-hand side that in this what's called general form, it looks very much like the quadratic equation, but it's not equal to 0. It's equal to either f of x or y, either one, because they are the same. All right, this is what's called general form. Below it is something called standard form. They are both forms of quadratic functions, and they provide us with different information. Okay. We had a form before. We had y equals mx plus b. That was for a linear function. But now we're going to look at the quadratic function. Okay. The graph of a linear function back in chapter, 8 and even back in chapter 3 was a line. Okay, so something like that, y equals mx plus b. But now we're going to look at the quadratic function, and its graph is a parabola. It is not pronounced parabola. It is parabola. Some parabolas open up, some parabolas open down. The very bottom point in an upward opening one, or the very top point in a downward opening one, is called the vertex. Even though it is just a point, which means it can be labeled x, y, because it's a very special point, the minimum in this parabola or the maximum in this parabola, we give it special names, and mathematicians chose to call it HK. H is just a special x, K is just a special y. A parabola is a symmetrical shape, meaning that on the right-hand side, it mirrors what you see on the left-hand side. There is a vertical line, which could be called its folding line, but instead, we will call it the axis of symmetry. It is a vertical line. All vertical lines are of the form x equals. Okay, so this is x equals. X equals what? Well, the x value, which is called h. X equals h is the axis of symmetry. So, there are two very important things. There are other important things, but within our course, all we're going to look at for a parabola, for the graph of a quadratic function, is we're going to look at the vertex, and we're going to look at the axis of symmetry. Primarily, we're going to focus on the vertex. Okay, now you might want to copy some of this down, and you can pause this recording anytime you want, so I'm not going to worry about speaking extremely slowly. Let's talk about, let's start over here on the right-hand side with general form. It's y equals ax squared plus bx plus c. Okay, this is general form. The direction of opening. Okay, does your parabola open up or does your parabola open down? Well, A which is right here, if A is a positive number, it opens up. If A is a negative number, it opens down. And by the way, even in our standard form, that much is still true. All right, now when you have this general form, I'm over here on the right-hand side. When you have general form, the vertex can be found by a formula. Remember that h is the x-coordinate of the vertex. And it seems like I've lost something, so I'm just going to tell you here that k can be found by a different formula. It is 4ac minus b squared all over 4a. Now that's kind of a tedious formula for the y-coordinate of the vertex. An alternate way to find this, or find f of h. I will explain that more in an example. That's function notation. What it means is, if you have the h coordinate, the first one, plug it into the function and out will pop the k. So I'll explain that more shortly. All right. The axis of symmetry is x equals h, a vertical line. So I think that's primarily what you need from general form. If instead your quadratic function, now I've moved over to the left side, happens to be in standard form, which looks like this, I want you to think back about transformations. Remember that this number on the outside tells you how it shifts up or down. The number on the inside tells you how it shifts left or right, opposite of whatever the sign is. Okay, so let's go on. A tells us the direction of opening. The vertex, how will I find the vertex? Well, the vertex is h and k. This formula has an h and a k in it. So now look at this version right here. And you notice that the h coordinate has a negative in front of it. You take the opposite of that sign to be h, but you take this to be exactly k. In other words, the vertex is sitting there staring at you from this. And I'll go over more of that in an example problem in a minute. The axis of symmetry is still x equals h. So all we're going to practice on some problems is finding the vertex. I'll talk about some other things. On your test, you're just going to be responsible for finding the vertex. I am not going to have you do math lab problems because I really wasn't crazy about the math lab problems. So we're going to do some problems together. I'm going to do the odd ones in this worksheet, and then I hope you'll do the even ones. All right. So I will copy down each problem as I need to, but you could print this out if you want. All right, the first set of 6 problems, and remember, I'm going to do number 1, number 3, and number 5. You do 2, 4, and 6. All of these are in standard form. Okay, and remember, standard form is f of x is equal to a parentheses x minus h, quantity squared, plus k. As we go on, I'm going to do number 7 and number 9. We're going to find the vertex. These are in general form, and that means f of x is equal to ax squared plus bx plus c. Okay, so we have standard form, we have general form. But no matter what form, I'm going to be asking you to find the vertex. So, problem number 1. Find the vertex. F of x is equal to x squared minus 1. All right, if this is standard form, then it's f of x is equal to a parentheses x minus h squared plus k. We need to identify what is the value of h and what is the value of k. Now, in this particular problem, you might look at it and say, well, I don't see anything in parentheses. Okay, if we don't see anything in parentheses, then what could be added or subtracted to the x? Well, the only thing would be a 0. Whoops, not k. That should be minus 1. Formally, this is what we're looking at. And I hope you can see that, and let me see if I can highlight this, that the h value is sitting right here and the k value is sitting right here. Okay, so h is the opposite of that number. The only thing is 0 is its own opposite, so h is 0. K is the same as what you see here, so it will be negative 1. The vertex for this parabola will be the point 0, negative 1. And although I'm not going to ask you this on the test, which way would this parabola open? Well, that's determined by a. The number sitting there in the place of a is an implied 1, which is a positive number, so it will open up. Once again, I'm not going to ask this on the test, but what is the equation of the axis of symmetry? Axis of symmetry is a vertical line, so it has to be x equals. It has to go through the vertex, so I will grab the x coordinate. It is the line x equals 0. So even though I'm not asking about the direction of opening, I'm not asking about the axis of symmetry, we could do those. All right, that was number 1. You do number 2. It should be similar. Number 3. So see, you're not going to do the math lab. You're just going to work these problems. Number 3. I have x minus 2 quantity squared. All right, once again, this is standard form. Standard form is f of x is equal to x minus h quantity squared plus k. All right, I can see h, and I don't seem to have anything there to go with k, which means it must have been plus, you guessed it, 0. All right, so h is equal to, remember, it is the opposite of this number. Opposite of h is negative 2. So remember, you do opposite for the h. So it is 2. For the k, you do the same, which is 0. That means that the vertex, that the vertex is the point 2, 0. Which way does this parabola open? Well, it's got an implied 1, which is a positive number, so it opens up. What is the axis of symmetry? It's a vertical line. It will be the line x equals 2. Okay, so that would be my axis of symmetry. That's the direction it opens. That's my vertex. Even though, and I've said this before, on our test, we're just going to be asked for the vertex. Number 4. Whoops, that's for you. Number 5. Number 4 should be like number 3. All right, number 5, it has f of x is equal to x plus 5 quantity squared minus 6. All right, in this one, remember standard form, x minus h quantity squared plus k. All right, h is equal to, it is the opposite of this number, so the h is negative 5. The k is, whoops, the same as this number. So it is negative 6. I always change the sign on what I have for h, but I keep that as k. So the vertex is the point negative 5, negative 6. It once again opens up. The axis of symmetry is the vertical line, x equals, grab that x value, negative 5. So I have done numbers 1, 3, and 5 on this worksheet, and I hope you recognize that standard form is pretty easy to use. You just have to remember to do the opposite of this value for h, but the same as this value for k. All right, now, general form, it might look a little more familiar, but it doesn't really tell us quite as much. So let's go to problem number 7. Now I'm in general form. I have f of x is equal to x squared plus 12x minus 2. All right. I need to find the vertex, but I am not given h and k. But I am given a formula for h. It is negative b over 2a. Another way that you might do this when you get to college algebra is that you might complete the square on general form. It will turn into standard form. Okay, but I'm just going to use this formula. And please remember that this is, well, let me write with something you can read. Okay, A is right here, this is B, this is C. So the value of A is an implied 1. That's going to be negative 12 over 2 times 1, which is negative 12 over 2, or negative 6. That's the h coordinate. Now there are 2 ways to find k. One of the ways is to use a formula, 4ac minus b squared all over 4a. Now the only problem with using this formula is that it's a little bit complicated. It's 4 times 1 times negative 2, that's a and that's c, minus parentheses 12 squared all over 4 times 1. 4 times 1 is 4 times negative 2 is negative 8 minus 12 squared is 144 all over 4. If I combine those, that's negative 152 over 4. do the division, and it's going to be negative, and 4 is going to go in there 38 times. That means that the vertex on number 7 is -6, -38. Now, I want to show you an alternate way to find k. Certainly, you don't need to do both of these, but k is equal to the function. Now, what's the function? It's right here. This is the function. The function evaluated at h. It's kind of like a t-chart. You're going to plug in -6 and you're going to crank out a y value to go with it. So I am going to, it is f of -6. Remember, that's your h value. So that is -6 squared plus 12 times -6 minus 2. Now, where did I get that? From the equation, from the function. Plugged in the x value, and I'm going to get the y that goes with it. That's going to be 36 minus 72 minus 2. That's going to be negative 36. 36 minus 72 is negative 36. Minus 2 is negative 38. That's just another way to get k. Same number, your choice which way you want to do it. This parabola will open up because of the +1, and the axis of symmetry will be the line x equals 6. Okay, I think you will find number 8 to be very much like that. And now let's go to number 9. It has f of x is equal to -6x squared plus 12x minus 6. All right, in this one, here's A, here's B, here's C. So if I'm going to use the formulas, h is equal to -b over 2a, and these are on your note sheet. So that's going to be the opposite of b, which is -12 over 2 times -6. That's -12 over -12, which is 1. There are 2 different ways you could get k. One way is the formula, 4ac minus b squared all over 4a, which is 4 times -6, which is a, times -6, which is c, minus 12, I'll put it in parentheses, squared, all of that over 4 times -6. All right, 4 times -6 is -24, and -24 times 6, negative times negative is positive 144, minus 12 squared is 144. That's over -24, but that's 0 over -24, which is 0. The coordinates of the vertex are 1, 0. The other way you could get k is to evaluate the function when h is 1. So I'll be glad to do it that other way. Or k is equal to f of h, which is f of, in this case, 1. And that will be -6 times 1 squared plus 12 times 1 minus 6. So I plugged in the 1 that I got as the x or the h in the place of x. All right. 1 squared is 1 times negative 6 is negative 6 plus 12 minus 6. 12, negative 6 plus 12 is 6 minus 6 is 0. Same answer. Okay, so you pick the way you like to do it to get the vertex. Now this one opens downward because of the negative sign. And the axis of symmetry is the vertical line x equals 1. All right, what I would like you to do is the even problems. And I'm going to put, if you want to pause the video right now, and then I'm going to put the answers to the evens coming up. So just pause the video, work on the evens, and you can check them as you go along if you want. Number 2, the vertex is the point 0, 4. Number 4, the vertex is the point negative 6, 0. Number 6, the vertex is negative 1, negative 3. All right, those are all from standard form. Now from general form, number 8, the vertex is negative 4, negative 17. And number 10, the vertex is negative 1, 14. So work on those and be ready to find the vertex of a parabola if you are given standard form or if you are given general form. And remember that all the formulas you need are on your blue sheet or on the note sheet. Okay, so I hope this helps with sections 11.5 and 11.6.